Friends, let us discuss about the introduction part of basic electronics. So first we will see what is semiconductor, conductor, insulator, so that we will go into the syllabus. First we will see what is atom. Okay, so this atom is nothing but it's like it consists of three tiny particles like protons, neutrons, and electrons. So protons and electrons are charge carriers. We know already aware about that, and this everything is made up of atom. So now based on this we can see the structure of this atom, how it will be. So here we can see the orbit. Along the orbit the electrons are revolving, and the lavender color part is called as nucleus. Okay, then followed by that let us discuss about the electrical properties. This based on the electrical properties, these materials are classified into three types. So one is conductor, another one is insulator, and the next is semiconductor. Okay, these are the three materials, that is conductor, insulators, and semiconductors. Conductors are nothing but the material which will permit the flow of electrons. Okay, the material which will permit the flow of electrons is called conductors. So insulator is nothing but the material which not allow the flow of electrons are called the insulators. So if you see about examples of conductors, that is gold, silver, and copper. And if you see about the examples of insulators, rubber, glass, Teflon, mica, etc. So now coming to this point of semiconductor. Semiconductor is nothing but the materials that the conductivity will falls between those of conductors and insulators. Put together is called as the semiconductors. Now we can see the energy band diagram. In the energy band diagram of all these three materials, it consists of valence band, conduction band, and also the energy band. Okay, so the most commonly used semiconductors are germanium and silicon. So these are the two semiconductors which used to build the semiconductor devices. So first diagram shows the energy band diagram of insulator. So here it consists of conduction band as well as the valence band. So in between the conduction band and valence band there is a band gap. So this band gap is varying between the insulator, semiconductor as well the conductor. Now let us discuss about the classification of semiconductors. So if you think about the classification of semiconductor, it is intrinsic semiconductor as well as the extrinsic semiconductor. So if you go for this intrinsic semiconductor, so intrinsic semiconductor means we are adding some impurity along with the silicon material. Okay, so this is the basic structure of silicon, and the atomic configuration and the crystalline structure has been shown. So here the symbol of the silicon is represented as Si. Then the atomic number of silicon is 14. Okay, here the diagram shows that the atomic weight is nothing but 28.086. Okay, so here this is pure semiconductor, that is silicon material. Here we can see only Si symbol. Okay, whenever this intrinsic, the operation how this moving particles are moving in the atom, this is silicon structure. You can visualize what I have explained and how it will be taking place actually. Okay, so followed by this we are going to classify the extrinsic semiconductors. Now extrinsic semiconductors are classified into two types. One is P-type semiconductor and another one is N-type semiconductor. Now we will see what is N-type semiconductor. So the N-type semiconductor is adding the pentavalent impurity. Whenever we are adding the pentavalent impurity atom along with the semiconductor material, that time N-type semiconductor will be obtained. Example of N-type semiconductor is arsenic, antimony, phosphorus. So example of N-type semiconductor is arsenic, antimony, phosphorus. So here the majority of the N-type carrier is electron and the minority carrier is holes. Okay. So if you come to this phosphorus, that is we can take the symbol as P. The atomic number is 15. So here along with the silicon semiconductor material, we have added a impurity called phosphorus. The symbol of the phosphorus is P. Now in the crystalline structure you can be seen clearly. So this is about the animated thing, how actually it has been happened, that is how the impurity has been added and how the N-type semiconductor is going to be obtained. The next we'll see P-type semiconductor. In the P-type semiconductor, how this P-type semiconductor will be obtained? By adding the trivalent impurity atoms such as aluminium, bronze, boron, etc. In this example, we considered the boron. The symbol of the boron is B. Okay. In the P-type, the majority carrier is hole and the minority carrier is electron. Here we are adding the impurity as boron. So in the crystalline structure silicon, the boron B is added. So this is the animated structure of the P-type semiconductor. Okay. Hope everyone understood. Thank you.